students. I am going to handle the course CS8391 Datastructures. Today the topic is threaded binary tree. As we all know, tree is a nonlinear data structure. It comes under Unit 3. What are the main objectives of this video means? From this video, you can learn about threaded binary tree, when the binary tree becomes a threaded binary tree, and what are the representations of threaded binary tree, then the types of threaded binary tree. So these are the objectives of this video presentation. First, what is threaded binary tree? So a threaded binary tree is very much same as that of a binary tree. Then what is the difference between binary tree and threaded binary tree means? How it stores the null pointers. So that is the difference. Okay. So for example, consider the below diagram. It shows the linked list representation of a binary tree. The root node is 1 and its left child is 2 and the right child is 3. And for 2, I am having the left child 4 and the right child 5 and so on. And most of the nodes are having the null pointers. Okay, since they don't have any child nodes, they all are represented as the null pointer. What is the drawback of storing these null pointers means? It is a wastage of space. So instead of storing the null pointers, you can replace them to store a pointer to the in-order predecessor or in-order successor of the node. These special pointers are called threads, and these binary trees are called as threaded trees. Okay. So once again, what is threaded binary tree? A threaded binary tree is same as that of a binary tree. Then what is the difference between binary tree and threaded binary tree means? How it stores the null pointers. Okay. What happens if we store the null pointers in every node? It is a wastage of space and it leads to inefficiency. So we can replace them by a pointer to the in-order predecessor or in-order successor of the particular node. These special pointers are called threads, and this type of binary trees are called as threaded binary trees. Okay. In linked list representation of a threaded binary tree, the threads will be denoted using arrows. So what are the two types of threaded binary tree means? One-way threaded tree and two-way threaded tree. So we move on to one-way threaded tree. The other name of one-way threaded tree is single threaded tree. If the thread appears in the left field, then the left field will be made to point to the in-order predecessor of the particular node. Such a one-way threaded tree is called as a left-threaded binary tree. That is like this. Okay. So instead of storing a null pointer here, you can replace it to contain a pointer to the in-order predecessor. So 2 is the in-order predecessor. The address of the node 2 is stored in the left field. Okay. So if the thread is made on left side, then it is called as a left-threaded binary tree. In the opposite, you can store a thread in the right field also. That is, instead of storing the null pointer in the right field, you can store the address of in-order successor of the particular node. Such a threaded tree is called a right-threaded binary tree. Okay, once again, what is one-way threaded binary tree? One-way threaded binary tree is also called as single threaded tree, the thread can appear either in the left side or in the right side. If the thread appears in the left side, it's called as a left-threaded binary tree. That is, it contains a pointer to the in-order predecessor. Sometimes a thread may appear in the right field also. That is like this. Okay. If it is, then that type of tree is called as a right-threaded binary tree. That is, it contains a pointer to the in-order successor of the node. Then what do you mean by two-threaded tree? In two-way threaded tree, the other name of two-way threaded tree is double-threaded tree. So here the thread will appear both in the left side as well as the right side field of the node. So if the left side is threaded, then it contains a pointer to in-order predecessor. If the right side field is threaded, then it contains a pointer to in-order successor. So a two-way threaded binary tree is also called a fully threaded binary tree. We will see with one example. So this is an example for one-way threading. Okay. So 1 is the root node and 2 is the left child and 3 is the right child. Node 8, left child is null and the right child is also null. Similarly for the node 5, its left child is null and the right child is null. So node 5 contains a null pointer in the right side field. So it is replaced to point to node 1. That is known as in-order successor. Okay. So here, don't touch the left side. In this diagram, we are concentrating on the right side field. So the other name of this threaded tree is right-sided threaded binary tree. Okay, that is this one. Right-threaded binary tree. Okay. Because for every node in the right hand side field, you cannot store the null pointer. Instead of storing the null pointer, you can store the address of its in-order successor. Okay, for example, 5, its right child is null. So we store the address of 1 here. It is the in-order successor. Similarly, for the node 8. Okay, for the node 8, it contains a null pointer. So instead of storing the null pointer, you can store the address of 4 here. Similarly for 9. For 9, you can store the address of the node 2. For 10, you can store the address of node 6. For 11, you can store the address of 3. But what happened for the node 12 means its right field is null because it does not have any in-order successor. Because its previous field is also null, so its in-order successor is null. So that's why for the node 12, both the fields are set to null. Okay. So that's about a one-way threaded tree. We move on to the two-way threading. As I told, in two-way threading, you can have both the left thread as well as the right thread. Okay. So consider this figure. So here, for the node 8, we don't have a right child, so it is null. Instead of storing null, you can store the address of 4 here. For the node 9, its left child is null. So instead of storing null, you can store the address of 4 here. Okay. Similarly, for the node 12, since its left child is null, you can store address of 7 here. So in the right hand side, we have shown the binary tree with two-way threading. Here we have both the left threading as well as the right threading. Okay. Now we move on to the memory representation of a binary tree without threading, with one-way threading and with two-way threading. Okay. We will see with one example. So the first figure shows the binary tree, the Linguist representation of binary tree with no threading. That is, see the figure for both the left child as well as the right child. Okay, for the left field and the right field, if we don't have any child, it is represented as null. So -1 is used to indicate the null pointer. For example, for the node 8, we don't have its left child as well as the right child. Similarly, for the node 5, we don't have a left child as well as the right child. Okay. So that is from this figure. The first one. For the node 5, we don't have the left child and the right child. For the node 8, we don't have a left child and the right child. Okay. So they are represented as the null pointer. In Linguist representation, -1 is used to represent the null pointer. The second figure shows Linguist representation of binary tree with one-way threading. So see the figure. In left field, we can store the null pointers, but in the right field, we cannot store the null pointer. Okay, instead of storing the null pointer, we have to store the in-order successor of the particular node. So this binary tree is called as right-threaded binary tree. Here the binary tree is threaded in the right side. See the figure. So that is a one-way threading. Okay, for the node 8, we don't have the right child. Instead of storing the null pointer, we are storing the in-order successor, that is the address of node 4 here. Okay, so the same thing here also. For the node 8, I don't have the right child. So instead of storing the null pointer, okay, I used the space to store the address of the node 4. That is the in-order successor. So its address is 9. So instead of -1, I have stored 9 here. Okay. So this is a one-way threaded tree. Whereas the last figure shows two-way threading. That is, see the left field, we don't have any null pointers. In the right field also, we don't have any null pointers except 12 and 8. Okay. 8 is not having any in-order predecessor and 12 is not having any in-order successor. That's why for these two fields, I have represented -1. Other than this, for all the nodes, instead of storing the null pointer, in the left field I have stored the in-order predecessor address. In the right field, I have stored the in-order successor address. Okay. For example, for the node 5, see the figure. See the figure. For the node 5, okay, for the node 5, the left field contains the address of 2. The left field contains the address of 2. The right field contains the address of 1. So we will check with the memory representation for the node 5. Okay, for the node 5, its left field contains the address 5, that is the address of 2, and the right field contains the address 3, that is the address of 1. Okay. So this is how the one-way threaded tree and two-way threaded tree is represented in memory. So with this, I have concluded the topic threaded binary tree. Thank you.